Yes. So welcome everyone, and today in this video आज स्टार्ट कर देंगे डिफरेंशियल इक्वेशन, राइट. फर्स्ट ऑर्डर डिफरेंशियल इक्वेशन का सॉल्यूशन यूजिंग ए easier algorithm. Okay, there are many algorithm for that, but we would use the easiest algorithm available to us. Okay. तो डिफरेंशियल इक्वेशन जैसे स्कूल्स में पढ़ाया जाता है, राइट, कॉलेज में फर्स्ट ईयर सेकेंड ईयर, तो वही डिफरेंशियल इक्वेशन का थ्योरी यूज़ करके वी विल गो अहेड. वी विल नॉट सॉल्व थिंग्स too much on pen paper. We will understand what are the concepts, and then we will start writing algorithm and solve it using computer, using Python, okay, and NumPy library. So that's pretty much it. Okay, so let's start. So we are going to learn about general form of first order differential equation. So if you remember, we might have studied the constant coefficient differential equation of this form: dy by dx plus ay is equal to b. Okay, so a comma b are constants, right? They are some real number constant. Okay, and we can find the solution using the integrating factor. Okay, if we multiply both side of the equation with the integrating factor, which was e to the power a dx integration. Okay, in that case we will be able to solve the equation. So let us go ahead and quickly solve this one. Right, so this is the integrating factor. What is this? This is nothing but e to the power ax. Fine. So dy by dx times e to the power ax plus e to the power ax a y is equal to b e to the power ax. Okay, and if you see this side, this is nothing but e to the power ax into y derivative with respect to x, right? Y is a function of x. Okay, so I should mention this here as well. Y is a function of x is equals to nothing but b times e to the power ax, and when we solve this by integrating, we will get y is equals to b times e to the power ax dx. Okay, and integration with respect to x. Fine, and then we will have to divide the both side by e to the power ax. Okay, so we will also have a c, a constant of integration here. So this was the idea. So we can use pen and paper to solve the differential equation of this kind. There are other first order differential equation which cannot be solved by pen and paper, or if we can solve by pen and paper, it is very tedious. Okay, so in place of b, if I replace b by, let's say, root sin x plus x cubed by 3, so the whole integration is going to get really complicated, and we will not get insight कि ये चीज़ क्या है. Okay, तो बिकॉज फंक्शन बहुत ज़्यादा कॉम्प्लिकेटेड हो गया है, वी कैन स्टिल अप्लाई दिस मेथड इज़ एप्लीकेबल, but the thing is you cannot solve it by hand. Integration is anyways difficult, right? Sometimes you cannot just find integration of any function because we don't have a formulation for that. Okay, so we will have to put the values on the system, okay, and try to find a solution using numerical method. Okay, that is what we are going to do. So this was the method anyways, but we are more interested in something else. What is that? The general form. Okay, general form is nothing but y dash is equals to f of x comma y. तो लास्ट वीडियो का पूरा डिस्कशन वाज about f of x comma y, how to compute f of x comma y, how to plot it, okay, what does it mean. So here we are going to do the same. Okay, so what we will do is basically plot f of x comma y on a 2D plane. Okay, right? So we can plot f of x comma y on a 2D plane, and that is nothing but equals to y dash. So what is y dash? Y dash is dy by dx. Fine. So y dash is dy by dx, which is nothing but slope of the solution curve. Okay, so the solution curve is going to be something like y of x plus c. Okay, so in the differential equation we know about the derivative of the solution. Okay, this is the solution, we know its derivative, okay, which is nothing but equal to f of x comma y. So if you give any point x comma y, we know the derivative. Once we know the derivative, we know how the y changes. ठीक है, तो डेरिवेटिव का मीनिंग क्या है? डेरिवेटिव का मीनिंग है डेल्टा y by डेल्टा x. If we fix delta x, okay, if we fix delta x to be h, ठीक है, तो डेल्टा x जो इंक्रीमेंट इन x है उसको हमने फिक्स कर दिया. दैट इज नोन एज द स्टेप साइज ऑफ द सोल्यूशन. न्यूमेरिकल सोल्यूशन का स्टेप साइज, okay. And delta y, can we get it? Yes. So delta y is nothing but equals to f of x comma y into h. Okay, this is delta y. So if we know delta y, then we basically if we are given initial point, let's say हमें पहले दे दिया गया था x naught comma y naught, this is known as a initial condition. Okay, तो differential equation का initial condition दे दिया है, then we can compute the next x1 y1. Okay, so we can compute x1 y1. How? Because we know how y is changing, because we know this function is known. So what is known is this function, and this gives the slope or the change. Okay, right? Okay, so if we know x1, what is x1? So x1 is nothing but x1 is equals to basically x naught plus the step size, how much we want it to increase. Okay, and what is y1? Y1 is nothing but y naught plus delta y. Okay, is it so? No. Or yes? Yes. So y naught plus delta y is our y1. Okay, I hope that I have made this thing clear. Fine. So what is delta y? Delta y is something we have computed, right? That is nothing but y naught plus f of x naught y naught into h. Okay, so that's pretty much it. So can we arrive at a general solution? Yes. So the general solution is we have to iteratively find. मैं समझा दूंगा, please try to understand this general solution. I'll give a brief explanation कि क्या हो रहा है. So what did we say? We say that y of, in general form, y of n is equal to y of n minus 1 plus f of, you know, y of n minus 1 comma x of n minus 1 times the step size. This is y of n. So y of 1 is nothing but y of 0, because 1 minus 1 is 0, plus f of y0 x0 into h. Okay, once we know y1, by the same description of the function, we can compute y2, which depends on y1. Okay, y1 and x1. So what is happening here is interesting. So we started with x0 y0. Okay, we started nothing but with initial condition. Then we got x1 y1. x1 is easy, we have fixed how much we want to go increase our movement along x-axis, so that is h. Yes, so we can also write this x n is equal to x n minus 1 plus h. Okay, and if we go h along x, what is the change in y? That is f of x naught y naught times h. So we add that to y naught to get y1. Okay, so that is it. So we take the change in y by change in x information. वो क्या है? Change in y by change in x is given, right? This is the slope. F of x comma y is given, and then we use the slope information to get the next point. Then we get the next point. Okay, then we get the next point. So we are basically seeing how much the function y is changing, and then we are plotting this curve. Okay, so that is how we are going to find solution. Okay, so that's pretty much it. This is also known as, if we plot f of x comma y for all x comma y, we will get something called as direction field that I want to show. So yes, direction fields are important to understand. So yes, so for all x and all y, I can find f of, let's say, for all x, the general term x is xi, general term y is yi. So for all xi comma yi, can I find the function value? Okay, so the function value is nothing but can be represented by a vector, right? And if I plot all this vector for all the points, I'll get what is known as direction fields. We'll plot all this, okay? We'll plot the direction fields, okay? So on the basis of where you are on xy plane, you can decide your trajectory based on direction fields. Fine. So the vector must have a component, x component and y component. So the x component of the vector is nothing but h, the step size. Okay, so it is moving h along x-axis, and the result is the resultant y movement is nothing but f of xi comma yi into h. So this is my ay, the y component. Okay, I want to plot all these vectors, right? So let's get started. It is going to be a bit lengthy code, little bit lengthy, but आप अगर follow करेंगे साथ में तो it would be easy. So the solution that I have shown you here, we will solve a function. Okay, so let me write the function here. So the differential equation that we are going to solve is dy by dx plus 0.5 y is equals to 0.1 x square. This is the differential equation that we are going to solve, and there is no initial condition for this. We will find the general solution, and then we see how initial condition affects the solution. Okay, first we'll plot the direction fields for the general solution, right? And then we will see how initial condition is going to affect our solution, right? So let's get started with our our Jupyter notebook. So I have opened the terminal, and let us open the Jupyter lab. Okay, I hope that everybody have added Jupyter lab to the path. Right, so by adding to the path, if you write Jupyter lab, it will open. So this was the last thing that we have done. Let me make a new folder, which is differential equations. New notebook. Right, so yes, so we have to import numpy, snp, import matplotlib dot pyplot as curve Okay, so now we have to decide that what are our x bound and y bound. So I want the solution of the differential equation starting from 0. Okay, so small x is equal to np dot linspace 0 comma 20. Okay, and I want to compute for 50 points. Y is also same, np dot linspace 0 comma 20 for 50 points. So this is 50 into 50, 250 2500 points. For 2500 points we have to compute capital X, capital Y, coordinate matrix. They were our coordinate matrix as we have discussed in the last video. So that is important to plot and to compute functions of several variable. So how do I get it? Mesh grid. इनपुट क्या होंगे मैश ग्रिड को? x, y. मैश ग्रिड को इनपुट होंगे x, y और yes, so we want to find solution to the differential equation. So y dash, how can I write? dy. Okay, can I write diff y? Diff y is nothing but a function of x which is equal to minus 0.5 times y, capital Y. We have to be careful, plus x into x times 0.1. Okay, so I want you to plot a two-dimension plot known as quiver. Okay, so this plot is known as quiver. It is useful for plotting vectors, right, on 2 dimensions. Right, so let us look at some of the code. So this uses the subplots without any change and quiver, right, great. So we can do that by our own knowledge. Okay, so let me insert a new cell. Okay, so I can insert a new cell, and here we will start plotting our figure. Okay, So the input parameters for quiver are capital X, capital Y, okay, U comma V. Fine. So what is U, what is V? Let us not worry about that, but just write the code for plotting. So the X, capital X and capital Y matrix, can we say what are their size? Their size is nothing but 50 cross 50. Okay, so 50 cross 50 is their size. So can we have a 50 cross 50 matrix having all H filled in there? Yes. How do we have that? So let me show something here. Let me write np dot ones, okay, and inside I will say 50 comma 50, and if I hit enter, I'll get a 50 comma 50 50 rows of ones, okay, and each row having 50 ones. And if I multiply with let's say 5.5, just to show you, everything will become 5.5. Is that correct? Okay, so this matrix is of interest to us. I'll tell you why. H, we have discussed H क्या था? The solution that we are finding, उसका step size, okay. Step size मतलब, right? What is the next point? Where is the next point? How far is the next point in along X dimension? Okay. On x-axis, how far the next point would be. So if you want closely packed points, more points, a finer solution, you will have to decrease the step size. If increase step size मतलब कम computation, decrease step size मतलब कम computation, more step size, what did I say? Decreasing the step size means more computation, okay. जब हम स्टेप साइज बढ़ा देते हैं तब कंप्यूटेशन डिक्रीज होता है. स्टेप साइज इज नथिंग बट वी हैव द एक्स मैट्रिक्स हियर, सो कैन वी से स्टेप साइज इज एक्स ऑफ 1 minus x of 0. Yes, we can say that. That is pretty much understandable, okay. So step size we know, we have computed the matrix. This is the U matrix, okay. So this is going to be the x component of the vector. This matrix has x component of the vector at all points, ठीक है. So at all points means there are 50 points along x, and these 50 points are stacked one upon the other 50 times. So for all points we have h as the vector component along x direction. Is it understandable? Or if I plot that, then you can have an understanding, and then again if I explain by writing, it would be easy to understand, right? What is V? V is nothing but the h times, okay, h times diff y. Okay, so this is v, and that's pretty much it, I guess. Can we plot this? So let us go ahead and see, are we able to plot? We did manage to plot, but problem ये है कि आप देखिए x component is constant, okay, y component is increasing, so the vectors are not uniform. I know कि ये समझ में नहीं आया होगा, but if you know how to make unit vectors, do you know how to make unit vectors? We have a vector x I cap plus y j cap. What is the unit vector in the direction of this vector? Let this vector be a vector. So this is a vector. So a unit vector in the direction of a vector would be nothing but x by root x square plus y square plus y by root x square plus y square. Obviously I cap and j cap ये तो 12th में पढ़ाया जाता है. Okay, so we will do the same thing here also. How can we do that? So yes, so how can we do that is by considering unit vectors. Okay, so we will not consider this u as component of unit vector. Okay, so we will call it u1, and we'll call the v as v1. Can we compute the magnitude of our vector v u1 x cap, a x cap, whatever notation, u1 x cap, I cap, okay, u1 along x axis, v1 along y axis. The magnitude of this vector is going to be np dot sqrt u1 times u1 plus v1 times v1. Okay, so this is the magnitude. Magnitude is this. So u is going to be u1, so it's a vector matrix. Okay, तो हर एक element of u1 has a value as h. Okay, if I divide that by mag, then I have the unit vector component, and if I divide v1 by mag, I will have the unit vector component along y axis, right? And all of them are u and v, both of them are in matrix form. So for all points we are having the components. Okay, so can we plot to see whether all the arrows are uniform? Yes, so all the arrows are now uniform. तो बट यहाँ से हमें क्या इंफॉर्मेशन मिलेगा? दैट इज़ द थिंग टू बी कंसिडर्ड. ओके, राइट. सो कैन वी हैव लार्जर एरोज हियर? यस, वी कैन हैव लार्जर एरोज, बट क्या करना है? द अमाउंट ऑफ पॉइंट्स दैट वी आर प्लॉटिंग इज 50 into 50, right? 2500 points. So we have to reduce those. So how can we reduce those? We will replace 50 by, let's suppose, 25. Okay, half of the points. And here also for this matrix you have to make those changes, and we should have some curve like this, some direction field like this. Okay, these are the direction fields. Okay, so in order to get the curve we have to follow along the direction fields, but we also need a initial point. Okay, but such a differential equation, for such a differential equation I already have a solution. Okay, for our differential equation we have the solution. So let me show it to you. Okay, I don't know how much it is visible, but I have found the solution using the initial method. Okay, fine, let me write it. It's not visible perhaps, so I have to write it. So what was our differential equation? Differential equation was y dash is equals to 0.5y plus 0.1 x squared. Okay, and the solution, the general solution comes to be here c times e to the power 0.5 x, okay, plus or minus x squared by 5 plus x by 2.5 plus 1 by 1.25. okay, this is the general solution, and this is nothing but y of x. So let me plot this. Okay, so is it a two-dimensional plot curve? Okay, so we need a x matrix perhaps, but we have used x तो यूज हो गया, तो अब कैसे करेंगे? we will use x2d matrix now. Fine. So let us get back to the notebook. For the solution, can I write x2d, okay, or x curve, just to say this is a different matrix for a variable. Okay, x2d is equals to np dot linspace 0, 20. How many points do we want? 100. Here there is no problem. Okay, and can we plot our function? So our function is yx, that is equals to c times np dot exp. Exp means e to the power, okay, 0.5 into x2d, right, minus x2d into x2d plus x2 2D divided by 2.5. Here we have a division also, that is 5, divided by 2.5 plus 1 divided by 1.25. So for each x at x in x2d, we will plot y of x. So can we plot y of x? Okay, so we can plot y of x also. How do we do that? So over here we can say ax dot plot x2d comma y of x. That's it. So can we go ahead and plot that? But we don't know c yet, so that might cause a problem. So we have no idea about c, but we can represent c in terms of y0 and x0 initial values. Okay, so c is nothing but y0 divided by np dot exp 0.5 into x, right, x0. So x0 and y0 happens to be initial condition. x0 is equals to, let's suppose, 0, and y0, let's suppose that is also 0. So basically in your equation you are setting x0 and y0 0, right? Okay, I made a mistake. c is not that, but c is y0 plus this thing also. I have to move that to the left side of the equation. Okay, now it's good. I should give perhaps another bracket. Okay, so that looks good. Yeah, so what was the problem? Problem is pretty obvious. Yes, so the problem is quite frustrating and irritating at times, but let us see what is the pretty obvious problem that we have. तो हमने कॉपी किया था yx से, right, in to find out the expression for c, right? तो यहाँ पर xd कॉपी हो गया है, x2d कॉपी हो गया है, but this is the the initial value of x, so this should be x0. ठीक है, तो x0 से रिप्लेस कर देते हैं. This is a part of a problem, है ना? And you can see the graph. Our field vectors are direction field vectors are plotted for y value which are less in comparison to the output of the function. Okay, तो आप देखिए फंक्शन का आउटपुट 2 into 10 to the power 6 जा रहा है. e to the power 6 means 10 to the power 6. Okay, so this is a problem. How do we solve that? So we can solve that by one way is, let us plot for let us limit our x bound to 5. Okay, so let me do that. We are not plotting for forever. Okay, I mean I have reduced 20 to 5. Okay, and we will have to do here the same thing. We don't want to plot the direction field. I am reducing that to 5. Okay, y, the direction field limits for y I have not specified yet, but let us say it to be 5. Okay, ठीक है, तो अभी देखते हैं 25 पॉइंट्स. ठीक है, चलिए, तो इट लुक्स बेटर, बट प्रॉब्लम अभी भी सॉल्व नहीं हुआ. वन मोर प्रॉब्लम इज दैट यहाँ पर नेगेटिव साइन है, दिस शुड बी पॉजिटिव. ओके, तो डिफरेंशियल इक्वेशन का जो सल्यूशन है, ये डिफरेंशियल इक्वेशन है, इसका सल्यूशन है ये वाला. ओके, तो अभी कुछ बेटर दिख रहा है, बट स्टिल वी हैव टू मेक सम चेंजेस, राइट. सो द डायरेक्शन फील्ड y bound needs to be increased to 14. Okay, let me do that. Y bound, how to increase y bound? Y bound can be increased in this way. Okay, so 0 to 14, 25 points, right. So this looks better. The curve is following the arrow, but arrows are not tangential. So this is a problem. Again, arrows are not tangential. How can we make it tangential? So everything is good, but if you see the scale of it, so we are here, the full length of x here is providing the 5 unit lengths, right? 1, 2, 3, 4 and 5 unit lengths are providing for 14 unit lengths here. So I have to multiply the x component, okay, by x component I have to multiply 14 by 5. So I have to do that, u1 into 14 by 5, and if I do that, magically sub arrows will be tangential to the curve, right? So is this magic? No, this is some geometrical aspect that we have to take into account. Okay, fine. So some tangents are falling on the curve. Okay, right. So this is good thing. We can do one more thing. We can reduce the points at which we are evaluating direction field. Okay, so we will get bigger arrows to examine and see if we are good or not. So I have to make appropriate changes. Okay, and you can see this arrows are tangential. Some arrows are falling on the curve itself. Okay, so this is good, right? I can also do something like I can start from 2 maybe, okay, or I can start from 4, right. Let's say I start from 4. That would offset the curve, but again we can plot for lesser values. Okay, in x we don't want to plot it till 5, we can reduce it to 3, and again you can see that the curve value is almost tangential. So you can see that the direction field vectors are almost tangential, but again the scale has changed. This is 17.5 and this is 5. Okay, so I have to multiply this 17.5 and 5. now they are exactly tangential. Okay, so you can see. So the idea was just that I can also increase it to 17.5, the y 17.5. yes, so it gives me better curve. So the idea is just this, that the direction field lines guide my evolution of the curve. Okay, and that is basically the first order differential equation till now which we have considered. So we have not yet made the solution to the differential equation. We done some cheating, ये तो मैंने पहले से ही सॉल्व करके रखा था. तो in the next video I will plot the solution, okay, numerical solution of the differential equation, and we will compare it. Is it also evolving with the direction field? Okay. So there were some issue with scaling according to the y bound and x bound. Okay, so that we can scale with variables also, so that we don't have to change every time. Okay, that we can do, right? A lot of things to be considered. Learning स्लो प्रोसेस होता है, तो धीरे धीरे लर्न करना है. और इफ़ यू आर if you find all this video interesting, and you can send this to your friend who is from any branch of engineering, it would help, right? So please do subscribe, comment, provide your suggestions, and it would help me to enhance my teaching. Okay, so thank you for being here. Okay, thank you.